Okay, today we're going to go ahead and continue with that characteristics of relations and functions that we discussed yesterday. Of course, yesterday there were certain terms that we went over, and as a matter of fact, before you could leave my classroom, I asked you what those words were. So, I'm not going to go over each and everything from yesterday, but just real quick. Some of those key terms that we talked about were origin and ordered pair. Of course, the origin refers to the intersection of the x and y axis. Remember, we've already got this down from yesterday, so you don't need to write it again. Ordered pair, we just said that that was the point x, y. We also had some other terms on the next page, such as a relation. Lanisa, do you remember what a relation was? That is correct, set of ordered pairs. We also have the word domain. Domain. Anybody remember what that word domain was? X. Domain was the x value. Domain is the x coordinate in a relation. And I'm going through this kind of quick, guys. Like I said, we've already covered this. If you weren't here, just get it from one of your buddies. Range. Domain is x. Range is the y. The y coordinate. Function. Function was a special type of relation. We said that a function was a relation or a set of ordered pairs where the what? The x don't repeat. So that's what a function is. It's a relation where the x's don't repeat. Then we went on to something called discrete and continuous. Discrete is when the points are not connected. Continuous is just the opposite of that. Continuous is when the points are connected, usually making a line or some kind of smooth curve. The two other words that we had were increasing and decreasing. The word increasing, all that means is as the x values get larger, the y values get bigger. As the x values get bigger, the y values get bigger. Decreasing is the opposite. On the decreasing, as the x's get larger, the y values get small. So these are some terms that we discussed yesterday. Today we're going to move on to something called function notation. So here's where we need to start on number 3. On number 3, we have something called function notation. Function notation is a method used to represent the point xy as x, f of x. Other letters besides f may be used in order to identify multiple functions by different letters, which we'll see in a minute. It is possible to use G, H, any other letter besides F. Now, on the first one they've given us here, they've given us a function. And the function we're working with here is f of x is equal to 2x plus 3. What they've asked me to do is find two different things. They've asked me to find f of 4, and they're also asking me to find f of negative 1. So what exactly do they want me to find when they say find f of 4? And find f of negative 1. Here's what they want, guys. All they want to know is, what would the y value be if we were to stick in a 4 for the x? So that's what we're going to do here. We're going to show our work. What would we get for our y value if we were to stick in a 4 for the x? Well, let's find out here. We're going to find f of 4 first. And the way we're going to do that is by replacing this x right here with a 4. So now instead of having 2x plus 3, now I have 2 times 4 plus 3. All I'm going to do here is some orders of operations. What do I do first? Do I multiply or do I add? You do, well, in this case it's multiplication, right? Because that's what we're doing here. 2 times 4 is 8, and 8 plus 3 is 11. Therefore, f of 4 is equal to 11. In other words, the y value is 11 if I stick in a 4 for the x. Now you'll notice right below that, this right here can also be written as a ordered pair. So how do you write f of 4 equals 11 as an ordered pair? Well, remember what we said here is that the 11 is the y value when 4 is the x value. So if that's true, what ordered pair am I looking at? 4, 11. 11 is the y, 4 is the x. Therefore, we're looking at the ordered pair 4, 11. That's it. That's function notation. Let's try that again. Put this time let's find f of negative 1. So to find that f of negative 1, we're still using the same function here, but this time we're going to replace x with a negative 1. Now, if it's too confusing and you don't remember orders of operation, guys, you can actually stick all of this right here into your calculator, just like you see it with parentheses and everything. So try that this time with your calculator. Put that in for me. 2 parentheses, negative 1 parentheses, plus 3. Stick it all in there just like you see it. And what number do you get? 1. Positive 1 or negative 1? Positive 1. Therefore, f of negative 1 is equal to a positive 1. That's function notation. But you can also write that as an ordered pair. What would that ordered pair be? Negative 1, 1. So they mean the same thing. The y value is 1 when the x value is a negative 4. Let's try a couple more here. Now on part A, you'll notice here they've given me two different functions. One says g of x, the other says h of x. So that means we're going to have to pay special attention to what I have down here. You'll notice they have different letters, which means I'm going to have to use one or the other function. So let me start with this first one here, h of 3. Obviously, because of that h, we're going to be using this function right here. So let's find out what h of 3 is. The way we're going to find what h of 3 is simply by using this function right here. But we're going to replace the x with a 3. That's all we're doing, replacing the x with a 3. Now, as I mentioned earlier, if you can't do this in your head, we always have the calculator for some help here. So, put that in your calculator. What is 4 times 3 plus 10? 22. Therefore, we have h of 3 is equal to a 22. In other words, the y is 22 if you were to stick in a 3 for the x. But I can also write that as an ordered pair. Anybody know what ordered pair that would be? 322. So for right now, what I'm going to have you guys do is write it both ways, both in the function notation, and then I'm also going to have you write it as an ordered pair, just so we get a little practice on both. Now let's try this next one here. Notice the next one doesn't have an h in front of it. This time it has a g in front of it, which means instead of using the function we used earlier, now we're going to have to use this. We've got to make sure we're using the right function. We can tell which function to use by looking at the letter. All right, so let's find g of negative 3. The way we're going to find g of negative 3 is by replacing x with a negative 3.
Please release all volleyball players. Please release all volleyball players.
All right, so we need to figure out what is a negative 3 squared plus 2. If you're not comfortable doing that in your head, put it in your calculator, see what you get. What is a negative 3 squared plus 2?
7.
7? Negative 7? Positive 7?
Negative.
Negative 7? Nope. Not 7. Not negative 7.
Negative 6. Positive 7.
Nope. What? 11. What?
Oh,
Negative
negative 3 times negative 3.
This says negative 3 squared. And a negative 3 times a negative 3 is positive 9. And 9 plus 2 is 11. So I know some of you scratching your head, but wait a minute. I put that in my calculator. My calculator said 7 or negative 7. The trick here is, guys, you got to put the negative 3 in parentheses. So just do that one more time for me real quick. Type it in with parentheses. Make sure the 2 is on the outside of the parentheses, the square. And what you should get this time is 11. So we need to be real careful when you're squaring negative numbers. They do need to be in parentheses. Otherwise, you're going to end up with the wrong answer. All right, so now that we know that g of negative 3 is equal to positive 11, which we can also write as an ordered pair. And that ordered pair would be negative 3, 11. So these are two different ways to say the same thing. Now the last one over there is the tricky one, because this time instead of just giving me a number, this time they gave me a letter and a number. But you guys have done this before. You've seen it back in Algebra 1. First thing I want to point out is notice that it does say g of a plus 1, which means I need to make sure that I'm using this function right here. So what I'm going to do is find g of a plus 1. And I'm simply going to replace this x with a plus 1. We're going to have to square that in a minute. Then we're going to have to add 2. Here's where it got tricky. Squaring an a plus 1. Does anybody remember how to square an a plus 1? What is a plus 1 squared? Well, that's part of it. Not all of it, but it is part of it. A squared plus 1, that's part, right? Still, not all of it.
A squared plus 1 squared.
Nope. Guys, what does it mean when you're squaring something? If I said, what's 5 squared? And multiply it by itself. So, what I'm asking you to do is take the a plus 1, and I'm asking you to multiply it by itself. So I'm going to put it out to the side. It's my little scratch board. Here's how this works, guys. And I know it's been a while. We use something called FOIL method or distributive property. Let's see if this sounds familiar. We multiply a times a, which is a squared. And then you multiply a times 1, which is 1a. Then you multiply 1 times a, which is 1a. And then finally, 1 times 1 is 1. 1 times 1 is 1. Does that look familiar? You remember saying something like that back in Algebra 1, geometry?
And then
Of course, that's not the answer yet, right? Because the 2 in the middle, what can we do with those 2 terms in the middle? Well, they're not going to cancel out, but you can put them together, right? They're like terms. So if I put those together, now what I have instead of 1a plus 1a is now I have 2a. So in other words, when I square the a plus 1, I end up with this a squared plus 2a plus 1. Now notice I still had a plus 2 back here, so let me go ahead and put that plus 2. We're almost done. There's one little bitty thing I got to do here. Anybody know what that one little bitty thing is? There's some numbers that I can put together. What 2 numbers can I put together? The 2 and the 1. These 2 numbers right here. So let's put them together. 1 plus 2. 1 plus 2 makes 3. So after I simplify this, I end up with a squared plus 2a plus 3. So g of a plus 1 is going to equal to that a squared plus 2a plus 3. That one was tricky. That is tricky. Oh, by the way, can I write that as an ordered pair?
No.
Yes, you can. Yes, you can. What's this ordered pair going to look like? Well, first of all, what did we plug in? What was the x value? A plus 1. So that's going to be the first thing. The second thing, our y value, is the answer. What answer did we get? We got an a squared plus 2a plus 3. So that's what the ordered pair would look like. A lot different from the other two, right? Hopefully we don't come across too many of those. But if we do, now you know what you need to do to solve. Now let's go to part B here. Part B says in function notation, we have the ordered pair x, f of x. They want to know which symbol represents the domain and which symbol represents the range. Let me start with domain.
X is domain.
Okay, domain, that one is the x, that's this x right here. Range. Usually we use y for range, but that's not what I have in this order pair. What am I using instead of a y? F of x. So that's what the range is, it's the f of x. So domain is the x, range is the f of x. Right. Part C there says, what are the benefits of using function notation? So why the heck am I using f of x? Why am I using g of x? Why h of x? Why not just use a y equals like we normally see? Well, the reason we want to do this, guys, what's that? Okay, that's one reason we can find a specific value. But more importantly, basically, it's to keep things organized. Okay, so I want you to write that down. We want to keep things organized. Because later on what's going to happen is we're going to talk about a lot of different things. And so that we can keep everything organized, we'll give it a specific letter. For example, I don't know, maybe we're talking about cats. And to make sure that we know we're talking about cats, maybe I'll use C of X, C for cat. Maybe we're talking about dogs. Then I'll use D of X, D for dogs. So it just helps us keep things straight. All right, let's go to number 4. On number 4, a couple of questions here. Most of us should be able to answer these 4 questions. Number 4 says label the X and Y axis. Well, you'll notice those have already been labeled. You got the X axis running across horizontally. You got the Y axis running across here vertically. So that part is already done for you. The next thing they do is want us to do is label the origin. Anybody remember where the origin's at?
1, 2,
No, the origin.
0.
It's at 0, 0. So let's go ahead and label this point right here. That right there is called the origin. That's the origin. Then they want us to label the quadrants. Where's quadrant number 1? Top or bottom? Top right-hand corner. There's quadrant number 1. We talked about this yesterday. Once you have the first one, then you just got to go counterclockwise. So that's quadrant 1. This one is quadrant 2. This one's quadrant 3. And then this one down here is quadrant number 4. So you start in the top right-hand corner, then you just go counterclockwise. Next thing they want me to do is graph the set of points. Graph these ordered pairs. So let's do that next. -2, 5. Let's find -2, 5. And let's put a point there. Then we're going to find 3, 4. Find the ordered pair 3, 4. Put a dot. Then we'll find -3, -5. -3, -5. 0, 4. 0, 4 is actually going to fall right on top of the y-axis. 1, 0 is going to fall right on top of the x-axis. +4, +5. Let's see, that's going to be right here. And finally, the last one, 0, -2. 0, -2 is going to fall right here on top of the y-axis. So all we've done is plot each of the points. Now let's answer part A, B, C, and D. Part A says identify the domain. Domain, is that the x's or is that the y's? X. So all it wants to do is list all of the x's. So go ahead and write down the x's for me. What are the x values in these ordered pairs? What are the x values in these ordered pairs? So if you look at those ordered pairs, the x values we had were -3, -2, 0, 1, 3, and 4. You'll notice when I wrote these numbers, I wrote them in order from the smallest to the largest. You don't have to necessarily do that as long as you've got them all listed for them. Okay? So if you don't have them in that same order, it's okay. You should have all those numbers listed. Range, same idea with the range. This time we want the y values. The y values. We're going to list every single y value that we have up there. Now I've gone ahead and listed those numbers in order from the smallest to the largest. So I've got -5, -2, 0, 4, and 5. All of these are y values. By the way, you'll notice that some of these numbers repeated themselves, but I didn't have to write them twice. Notice that I only wrote them once. That's good enough. Okay. So we're on part C here. The question is the relation a function?
No.
Why not?
0.
Yeah, remember, in order to be a function, x's cannot be repeated. And in this case, there were some x's that were repeated. And in this particular case, it was the 0 that was repeated. So this is definitely not a function. Not a function because we got some x's that repeat. And the last question we have here, is this continuous or discrete? And why would we call this one discrete?
Points can't connect.
That's right, because these points are not connected. It is discrete, and we know it's discrete because the points are not connected. because the points are not connected. We have two more. We got number 5 and number 6. What I'm going to do on number 5 is, you'll notice there's two different graphs with the same questions. What I'm going to do is one of them, you're going to do the other. Then I'll do the same thing for number 6. I'll do one of them, you do the other. So make sure that you are following along here, because you're going to get one by yourself. All right, so for number 5, we're given a graph. And what they want us to do is identify the domain, the range, tell whether it's a function, whether it's continuous or discrete, and so on and so on. First thing I want to point out is this graph that I have here. Notice that it is different from this graph that we were just working with over here. The question is, how is this graph that I see here different from this graph that I have right here? It has numbers on it. Okay, what else? What's that? It's continuous. What do you mean it's continuous?
When the dots is open.
Dots is open. Okay. We're starting to see some things here. Notice over here on the first graph that we did, notice how we have points, ordered pairs, dots that are not connected. What do you notice about these over here? The dots are connected. So one of them has the dot connected, the other does not. That sounds familiar. Didn't we have words for when they're connected and when they're not connected? When they're not connected, we call them what? Discrete, which is what we had last time. When they are connected, like I have here, we call it continuous. So if you look at the fourth question here, it says, is it continuous or discrete? This one happens to be continuous. It is continuous because we have points that are connected. Now, the reason I bring this up first is because when we write our domain and range, we're going to have to do this a little differently from what we did a second ago. Earlier, I just wrote down individual numbers. I can't do that on this one because we want all of the x values, not just the x values for this point, this point, this point, and this point. I want the x values for everything, including this point here, including this point here, this one, this one, this one, this one, this one. All these points, I want to know what are the x values. And if I try and write each and every one individually, this won't do it. Okay? It's too much work. So we're going to do it a little different. So here's what we're going to do to write the domain. First of all, notice the x values. The x values go from here all the way to here. The smallest x value I have on this graph is this one right here, which is a -2. And the graph continues all the way till we get over here to this x value. What is this x value? 4. So what I want to do is I want to say that the x values go from -2 all the way up to the +4. So here's what I want you to do to write that point. We're going to write it as -2, which is the smallest x value, is less than x, which is less than or equal to a 4. So what I'm saying here is that I'm including everything that falls between -2 and the +4. Now, if you look closely there, you'll notice that one of those inequality symbols has an equal sign, the other does not. So what happened? Why does one have the equal sign, the other does not? Anybody remember why?
Because one is open.
There you go. Because one dot is open, which happens to be this one right here. One dot is open, the other is closed, which is why one has the equal sign, the other does not. Meaning we want to include the one that's closed circle, but we don't want to include the one that's the open circle. So the domain for this graph is between -2 and +4. Now let's go to the range, the y values. Let's look at the y's. So if we look at the graph again, you'll notice the y values on this graph. The smallest y value we have is down here at the bottom. What is that y value for that point? What kind of 4? -4. Notice the largest y value we have up here is what? 3. 1, 2, 3, right? So the y values here start down here at -4, and they go all the way up to a +3. That's what I want to write down. So our range is going to be -4 is less than or equal to y, which is less than or equal to a 3. By the way, notice that I am using a y because we're talking about range here. Also notice how both of these inequality symbols have the equal sign. Why do both of them have an equal sign this time? Well, not
They're
necessarily,
closed, the dots
because
are
both of the dots are closed. We only leave it without the equal sign if it's an open circle like this one was. Next question is this considered to be a function? What do y'all think? Is that a function? And why would we call this a function? No x's repeats. Okay, so yes, this is a function because none of the x's repeat. Next one says, on what intervals is the graph increasing? So you'll notice that part of this graph goes up, part of it goes down, and then it goes up again. So there's two parts where it increases. It increases here, and it also increases here. So we want to identify those two pieces of the graph. So here's how we're going to do that. This first part, it increases from this x value to this x value. So it increases from the -2 until you get all the way to, until we get to what's this x value here? And what is the origin? 0. So that's going to be one of the intervals. So one of the intervals is going to be between -2 and 0. -2 is less than x, less than 0. But there's another piece of the graph where it also increases. That's that other green part that I've highlighted. This interval right here, if you look at the x values, it increases from the +2 all the way until you get to the +4, which is what this part is saying right here. It increases from +2 until you get to the +4. The last question wants to know, where exactly is this graph decreasing? Where is it going down? Well, let's look at the graph here. It's going down from here until you get to here. What is that interval? Look at the x's. It goes from 0 all the way until you get to the 2. Therefore, the interval here is between 0 and 2. 0 is less than x, less than 2. That's where it decreases. That's where it's going down. So in a minute, I'll let you go and do the other graph. It's going to be very similar to what we've just done here. So you have some examples to look at.
But how many points are on that?
What do you mean, how many points?
On the next one, there's only one graph point.
Yeah, you'll notice that this one over here, I think you're talking about this point right here, right?
Yes.
You'll notice that it has a arrow rather than a point. And what does that arrow mean?
It keeps going.
That it keeps going. So this graph is going to go, 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 go. So when you write your domain range, you need to account for that. You need to say, hey, it doesn't stop. It keeps going and going and going. But I'm going to let you play with that first, and then if you're having trouble, then I'm going to help you out. All right, next one, number 6. Like I said, I'm going to do one of them, and then you're going to do the other part. So on number 6 here, they've given us an equation. And what we're going to do first is fill out the table, and then we'll sketch a graph of this table. So here we have y is equal to 2, absolute value of x minus 1. So let's fill out the table first. You're going to help me out here. We're going to plug in a -3 for x. So a -3, what's a -3 minus a 1? -4. But I want to take the absolute value of a -4. Anybody know the absolute value of a -4? Can calculators do absolute values? Yes, they can. Where is the absolute value on your calculator? Turn on your calculator. Let me show you where it's at, guys. On your calculator, what you're going to do is you're going to go to the button that says Math. Like that. Then in Math, you're going to move to the right, up at the top where it says NUM. Want to see that? And the very first thing you're going to see there is ABS. What do you think ABS stands for? Absolute value. So select that one for me. When you do that, you'll notice now what you have is those little bars that show up. So now you can type in -4. So type in -4
-4 for what?
inside the little bars that you just got. And then hit enter.
You don't put -3.
What we did -3 minus 1. All right, so what was the absolute value of the -4? +4. We're almost done. What do you get when you multiply that 4 with this 2 that's in front here? 2 times 4 is 8. So the y value is 8 when we plug in a -3. Now I notice some of us are a little bit lost there, so we're going to try that again. Let's try it again. Let's use a -2 this time. If I put a -2 in for the x, a -2 minus a 1. A -2 minus a 1 is a -3. But I want to know what the absolute value of a -3. The absolute value of a -3 is +3. And if I take that +3 and multiply it with this 2 over here, 2 times 3 would be a 6. So 6 is the next y value. Let's keep going. If I plug in a -1, -1 minus 1. -1 minus 1 would be a -2. But the absolute value of a -2 is +2. And if I take that 2 and multiply it with the 2 in front here, I get a 4. I'm going to do one more here, and then I'm going to try let you see if you can do the other 3. 0. 0 minus 1. 0 minus 1 is a -1. The absolute value of a -1 is 1. And 2 times 1 is 2. So see if you can finish up those last 3 points. Fill out the table. Use the calculator if you need it, guys.
It's gonna be the absolute value.
Yes, we're always taking the absolute value, so you should always end up with a positive number. When you take the absolute value, you always get a positive number.
But if it's got that equation, then it's gonna have the D graph, right?
Okay. Well, that's what we're going to find out in a minute. Once we get all these ordered pairs down, graph it, see what we get. Anybody got the next y value? What should go right next to 1? 0. Right next to 2 is a 2. And then right next to 3 is 4. If you didn't get those numbers, you need to fix them. Those are the correct numbers. Now that we have the table filled out, now let's come over here and sketch a graph of these ordered pairs. The first ordered pair is -3/8. So let's find -3/8. Put it down. Then let's find -2/6. -1/4. 0/2. 1/0. 2/2. And finally 3/4. Now keep in mind, guys, this table that they gave us, this was only a few x values. There's a lot of other x values that I could have plugged in, which means that there's a lot of other x values that I could have plugged in. Then obviously there's a lot of other y values as well. So what we're going to do is we're going to go ahead and connect these points. Notice they do follow a pattern. They make this V shape. We've seen this V shape before. All right, right below that, identify the domain and the range. What is the x's and what is the y's? What are the x's in this graph?
-3, -2, -1, 0, 1, 2, 3,
Okay, that's some of them. I want the rest of them.
4, 5.
Remember I said there's a lot of other x values that we could have plugged in. Those aren't the only ones. But Okay, well, you're right. We're talking about all numbers. I want to be able to say that I want all the numbers. What are we going to say? All real numbers. Okay, so our domain here is going to be all real numbers. In other words, any x value that's positive, any x value that's negative, any decimals, any fractions, anything I could have plugged in for x. Domain is all real numbers. Range, on the other hand, is just the y values. And the y values, you notice, are just positive numbers. Why do we just want those positive numbers? Well, because we're taking the absolute value. So the way we're going to say that is that the y values have to be greater than or equal to a 0. That's another way of saying all positive numbers. All right, next question is this considered to be a function? What do y'all think? Is it a function? Yes. Why is it a function? X's don't repeat. This is a function because the x's didn't repeat. Continuous or discrete? Well, if I look at just the individual points, you're right, it would be discrete. But are those the only x values that I can plug in? No, there's a lot of others. So this is actually continuous. Continuous. We're looking at the equation itself. And finally, the last one here, what parent function best represents this data? V-shape. Which one of those functions that we talked about looks like the V-shape? It's the absolute value. So the parent function that best represents this data is the absolute value parent function. All right, so what I want you to do is, now that I've given you some examples, you're going to go back to number 5 and number 6, and you're going to answer those questions for me, very similar to what we did together. So answer number 5 and number 6 for me.